today's topic about inequalities. Now, solving inequalities is very similar to solving equations, but you have to be very careful about the procedure when you simplify the inequalities. The only thing you have to be careful is when you multiply not multiply the inequality by a negative number, you have to reverse the direction of the inequality symbol. Okay, so inequalities will be in the following. That's the key point. So let's see. Let me write down the format. Suppose you have an inequality A less than or equal to B. Okay, then this will be the same if you multiply by a positive number. K is positive. Okay, now this will be equivalent to this inequality if K is negative. Okay? And K could be in the denominator. Okay? K is not necessarily be integer here. So it's the same, when you divide by K. Divide by K is the same as like multiply by 1 over K. So if I change the same holds, if I replace this, the same holds if this symbol is replaced by this strictly less than symbol. Okay, and that's all we needed to know. Okay, so let's take a look at the following example. If you want to solve this inequality, 2x minus 3 greater than 7, right? So everybody probably knows how to do it. I just need to show you this example first. Okay, so you move -3 to the right-hand side. Okay, so you get 7 plus 3 here. Okay, then 2x is greater than 10. Now you have to show step by step. Okay, so let me repeat again. When you do the homework, okay, you get a homework assignment sheet, but do not just write down the answer next to the problem. You have to work on a separate paper and shows all the details like what we're doing here in the class. Then you divide by 2, then you get 5. Okay, so x greater than 5 is going to be the answer. Now there are several ways to express the answer. Okay, the interval notation. Okay, interval notation. You can write the different forms. X greater than 5 is one of the answers. The second one is you draw the coordinate line, and this is 0, that's a 5, and put a little circle here, like this one. It's also notation. The third notation, this is called a coordinate line, okay, in notation. The third notation is the interval from 5 to positive infinity. So there are 3 different forms, okay, to answer your question. Okay, that's what I want to say here. The second problem is this inequality. Okay. Now, here we have to be very careful. This is the place people usually make mistakes. Okay, you step by step, right? You multiply both sides by 3. Okay, so you get negative x less than not multiply positive number 3, so it'll be 6, right? You multiply both by 3. Then you multiply. Here's you multiply by 3. Okay, then you multiply by -1. So you get an x. Now you change the direction of the inequality. Okay, so that's what you get. X greater than -6. And then you can use the interval notation. It's very popular notation. The answer is going to be -6, positive infinity. Okay, this is an interval notation. Okay. I'm going to ask you to try the following problem. I hope everybody can get the right answer. Okay, so I said that solving inequality is similar to solving equations. Now, this is a linear inequality, okay? They are nonlinear inequality, then it's a little bit more complicated. Okay? So solving linear inequality is like solving linear equations. Okay, please work on that. I hope if you have an answer, just post on the chat window. Don't type anything else in the chat window, okay? And show me your work. Okay, and not show the answers. Okay. Okay. Sounds good. I'm glad to hear that. All right. So to do that, you can move. It's up to you. You can move x to the right hand side. Then let's do the opposite, right? So you move 2 to the left hand side. You move 2x to the right hand side. You can do like that. Okay. Then here's 8. That would be 3x. Then you divide both sides by 3, and you get x. So this is a simplified inequality. You can say, oh, x greater than 8/3. Okay. So the traditional way is x is always on the left side. The number is on the right hand side. So this is the answer. Okay. Now let's try a slightly more complicated problem. You have 1/2 x minus 3 less than or equal to 3 minus 2x divided by 5. Okay, let's try this. Okay, I want you to do this. Okay. Anyway, have answers? All right. I got several answers here right now. So let me work on this. Okay. Great, Eric. You're doing always great. Jasmine, Taylor, James, Stephanie, oh, Stephanie. Nice to see you, Stephanie. Okay. Okay, great. You get the answer, and they all have the same answer. I'm great. The rest of the students haven't shown me the answer yet, but I wish you can finish it as soon as possible. Okay. So the first thing you have to do like this. This is this involves fractions. So similar to the linear equations, it's better to get rid of the fractions. How to do that? You see, in order to get rid of 2 and 5, you have to multiply by 10. Okay, you multiply by 10, then Yeah, you multiply by 10, then the left-hand side will be every time multiplied by 10, so it's a 5x minus 30, right? And less than equal to 2 times 3 minus 2x, because 10 divided by 5 is 2. Okay, so this could be, let's just write this. This could be 6 minus 4x. Okay, then you minus 4x to move it to the left-hand side. So you will get 5x plus 4x. Then you move 30 to the right-hand side. It becomes 30, okay? So the left-hand side is 9x. The right-hand side is 36. Then you divide both sides by 9. And that is going to be 4. Okay, so x is less than or equal to 4. That's probably the easiest way to, because it's much quick way to deal with the integers, not, okay, fractions much more difficult to handle. Okay, every step you have to do, addition or multiplication for fractions, that takes much more time and it's easy to make mistakes. So my suggestion to you is to get rid of the fraction first, okay? And now I'm going to give you another problem, okay? So I hope everybody can give me the answer quickly. Yeah. You have to get the answer quickly and correctly, okay? So we have several names and haven't shown me the answer yet. May, okay. Chu Tian Chen, Grant, Justin Lee, Nina Zhu, Qing Lu. Okay, Vincia Lee. So I want to see your answers. All right, good job. Okay, so first thing you have to do is to find the least common multiple of 2 and 3, which is 6. You multiply it by 6. You get 3x minus 2, then it's equal to x minus 3, right? Then you multiply this out. 3x minus 6 less than equal to 2x minus 6. Okay, so negative 6 is canceled out. So you get 3x minus, right? So 3x minus 2x less than equal to 0. So x is less than equal to 0. That. Good job, Justin. Okay. All right, now here's another one. Solve x plus 2 divided by 2 minus x minus 4 divided by 5 greater than 1. Okay, so please work on this problem. Then we are going to discuss another type of problems. All right, so we have the answers, several answers. Okay, great. So let's do this. Again, you multiply by 10 on both sides. So 10 divided by 2, which is 5, right? So let's just put the 5 there. 5 times x plus 1 minus 2 times x minus 4 greater than 10. Right. Then you get rid of parentheses, so 5x plus 5 minus 2x, be careful, negative 2 times negative 4 is going to be 8, greater than 10. So you have to show all the steps, okay? So when you finish the homework, and maybe you or your parents check your homework answers. If they find the answers wrong, and maybe you can easily figure out the ways mistakes and try to avoid such mistakes in the future, okay? Then you look at simplifying this. 5x minus 2x is 3x. 8 plus 5 plus 8 is 13, greater than 10. Okay. Then you move 13 to the right hand side, so you get negative 3. And then you divide both sides by 3, so x is greater than negative 1. Okay, good. Now, okay, let's talk about new type of inequalities. The new type of inequalities, if you have two inequalities, A less than B and B less than C, sometimes they can combine into one simple inequalities. Actually, they involve two inequalities. So those two inequalities are equivalent because they have the same direction and the b, they share the same b here. So that's why you can write in this form. For example, negative 2 less than x and x is less than 5. Then this is equivalent to the following notation: x is greater than negative 2, less than 5, or can even less than equal to 5, then less than equal to 5. Okay. Now, what does that mean? Those two inequalities. That means the variable x satisfying both inequalities. We use the and. And means that both must be satisfied. Okay. So the notation will be like that. If we use a coordinate line notation, this is 0, that's negative 2, that's a 5. Okay. So to describe the solution would be x is greater than negative 2. So you put a circle here, but x must be less than or equal to 5. So that is the notation. Okay. And if we want to use the interval notation, okay, this is a coordinate. If we use the interval notation, that'll be negative 2 and the 5 and including 5. So that's why I use a bracket. Okay. So you understand right now, right? So you can have one equation here, inequality, with two inequality symbols. Okay. All right. So let's take a look at the following inequality. Solve 3 less than x minus 4 less than 8. Now, how do you solve it? This actually has two inequalities here, 3 less than x minus 4, and, okay, x minus 4 less than 8. Okay, so you can, so that x must satisfy those two inequalities. So you have to solve each of them. So you move negative 4 to the left-hand side, and here you move negative 4 to right-hand side. Okay, then you simplify the 7 less than x, x is greater than x less than 12. So you can combine them again. X is greater than 7, less than 2. Now, this is a detailed solution, right? But to save time, you see, to save time, you don't need to write in this way. you can do simultaneous at the same time. Let me show you. Okay, x minus 4 less than 8 greater than 3, and you move negative 4 to the both sides at the same time. You can do like that. Okay, so it would be x less than 12 greater than 7. Immediately get this answer. So that saves you space and time. But you remember, you have to simultaneously move the same number to the both sides. You cannot say, I'm going to move 4 to the left-hand side and totally forget the right-hand side. Okay, that's the key point. Okay. Yes. So like here, you see, we move the term to the both sides. That's why I have a same x here. Then you can combine them at the end. Okay. So let's do the following problem. Solve 3 minus 2x less than 7 greater than 4. Okay, please do this problem. So what do you get? Eric, Justin, James. I'm trying to see. James, look at the answers. I think the answer is wrong because when you read as an answer, negative 1/2 is less than negative 2. That's impossible. You see, if you erase the x in the middle, can you still read it in the order, right? So what I'm going to do, I'm going to move 3 to both sides. I draw the picture here because otherwise we'll forget one side. So I get 4 minus 3 less than negative 2x, 7 minus 3, okay? Then I have a 1 less than negative 2x less than 4. Then be careful when you divide by 2, negative 2. When you divide by negative 2, you have to change the order of direction. You have to change the direction of the inequality. Right? So you have to be 1/2. It will be 1/2 greater than x greater than negative 2. Okay? Now, after you solve this inequality, suppose you cover up x in the middle. Does this make sense? Yeah, negative 1/2 is greater than negative 2. Then you can see this should be the right answer, right? So James, if you got the first time you got the answer, you just cover the x to see if this is still true or not, right? If you forgot to change the direction of the inequality, then it becomes like a negative 1/2 is less than negative 2. That's impossible. Negative 1/2 is larger than negative 2. Okay? So then you see the answer is wrong. All right. But sometimes those two inequalities are not combined into one line. So you have to solve them separately, like x plus 10 is greater than 11 and negative 4x plus 1 greater than negative 11. Okay. Now, to solve these two inequalities together, that means you have the some unknown number which satisfies both inequalities at the same time. So what you do is you solve them separately and combine them if possible at the end. So x is greater than 11 minus 10, right? And then x is greater than 1. On the right-hand side, that would be negative 4x greater than negative 11 minus 1. So negative 4x is greater than negative 12. Now, when I divide both sides by negative 4, I will get 3 here. So x is less than 3. Now I can combine them. How can I combine them? Because x is greater than 1, but then x is also less than 3, right? So then I cover the x, I can see that 1 is less than 3. So that makes sense, okay? So that sometimes that do not match. It's impossible. For example, x is less than 1 and x greater than 3. Then you have troubles, okay? You cannot combine them, so then there's no solution because x cannot satisfy those two inequalities at the same time, okay? So if I change, yeah, so let's look at this problem again. Another problem, okay, solve x minus plus 2, greater than 5, and x, negative x plus 3 greater than 1, okay? Can you solve this problem? All right, anyone have answers? Okay, it says no solution. Okay, so let's do this separately. So x is greater than 5 minus 2, 3. And here's negative x is greater than negative 2. So then x is less than 2. But that is actually the end, right? X is greater than, so x greater than 3 and x less than 2. I think this is impossible. So that's why no solution. Okay, there'll be no solution. Great. All right, so now let's understand the absolute value. The absolute value x has two meanings here. Okay, and this actually it can be written as x minus 0. So this is the distance between the origin and x. Okay, that's the geometric meaning of the absolute value x. If you look at the coordinate line, x could be on the left, x could be on the right hand side. Okay, so that is the distance. the distance is going to be absolute x because x could be negative, right? So that means if x is less than a is positive, okay? Let a be positive, okay? So that means the distance between 0 and x should be less than a. What kind of interval you're going to get? So this is a, here will be negative a. So this is the interval containing all the x satisfying this inequality, okay? So actually, this is equivalent to saying that x is less than a greater than negative a, okay? Now, if x is greater than a or equal to a, no, just make it different, then this will be outside the interval. So then you have x is less than or equal to negative a, or here remember, or x greater than a. So this is or, not and. This one actually is x is less than a and x greater than negative a. Okay, so that's the n. The other one is use or. Okay, or means either this or that. It cannot be the same time. Hold. Okay. All right, so this is a general idea. All right, so let's look at the let's look at the following inequality. Solve the inequality x minus 1 less than 2. Well, if you can solve it using geometry. So x minus 1 absolute value is going to be, this is a 1, right? So this is actually is going to be the distance between x and the 1. So the distance is going to be absolute x minus 1, which should be less than 2. So that means start from negative 2, 1, and then you can, from here you can show the picture, right? So that is the interval. All the points in this interval will be the solution if you use a geometry picture. Okay, right? All the points. So that will be x less than 3 greater than negative 1. Okay, right? That's the center of the interval, which is 1. Now, if you don't want to use a picture, then you can how to solve it. So you can solve it in the following way. Absolute x less than 2 is equivalent to x minus 1 less than 2 greater than negative 2. Okay? Then you move 2 to the both side, move 1 to the both side. And the left hand side is negative 1, the right hand side is 3. So you get the answer. Okay? All right, so I'm going to ask you to do the following problem. Okay. Solve this inequality 1 minus 4x greater than 7. Let's try. Yeah, let's do this. Okay. Now, let me finish this one. Okay. So one absolute value of 1 minus 4x is greater than 4. Now that means 1 minus 4x will be less than negative 7, or, okay, or here. And x, 1 minus 4x is greater than negative 7, greater than positive 7. Either is larger than 7 or smaller than negative 4, right? Negative 7. All right, so you have to solve those two inequalities separately. So I'm going to move 1 to the left-hand side, minus 8. Or, and I keep writing here, negative 4x is greater than 7 minus 1, 6. Okay? Then, be careful, I divide both sides by negative 4. So negative 8 to divide by negative 4 is going to be 2, but you have to change the direction of inequality. And here, I also have to change the direction of inequality. 6 divided by negative 4 will be negative 3 over 2. Okay, so that's okay. Now, x is greater than 2 or x is less than negative 3. Okay, Chu Tian, your expression is wrong. Okay, negative number cannot be greater than 2. Okay, you have to type x less than negative 3 over 2 or x is greater than 2, right? So that, yeah, you have to type O here, okay? That's the answer. That is the answer. You cannot combine them into one inequality, okay? But if you use a notation, okay, watch out. If you use a notation, here's 0, here's 1, here's 2, right? And here is going to be negative 1, negative 2, negative 3 over 2 is here, right? So x is greater than 2, it does not include 2, would be this one. X is less than negative 3 over 2 will be this, okay? So this is an interval for the this is a coordinate line expression. Okay, yeah. Interval notation will be different. For this interval on the left, it will be negative infinity, negative 3 over 2. The interval here will be 2 and positive infinity. How to combine them? For interval, you can combine them. You can use the following notation called the unit of this. So the answer in the interval notation will be, and usually you have to say or, but I'm going to use this one. That's called the unit of these two intervals. Okay. So if when you read it, you can say either this interval or that interval. And that's called interval notation. Okay. Some notations here. Okay. A, this one is called the unit of A and B. Okay. And this one is called the intersection of A and B. So geometrically, how to draw that? So if this is a A, that is a B. Okay. So the unit of let me draw that. Okay, this will be the unit of this will be the unit of the two sets. Okay, this will be the unit of this two sets. That's A, B. Okay, this is A, that's a B. And the intersection will be, okay, so this will be the intersection. Okay. That is A and B, the intersection part. Okay, so those are the notations we should know. All right, so let's take a look at the next problem. Okay, let's take a look at the next problem. Okay, I'm going to ask you to do the following. So 3 minus 2x less than 5. Please solve this inequality. All right, looks like you get the right answers here. Okay, so first of all, you do this. 3 minus 2x less than 5 greater than -5. Okay. Then you move 3 to the both sides. You get 5 minus 3 is 2. -5 minus -3 is -8. Now be careful when you divide by -2 on both sides. So you change the direction of the inequality. So 2 divided by -2 is -1. -8 divided by -2 is 4. Okay. So that is answer. Good. All right. So now I'm going to do another problem. Okay. This is not an easy problem. Okay. Now, these days, many college students, when they enter university, before they take calculus courses, they have to take a pre-calculus course. The first chapter is about inequalities. And a surprise to me, there are a large number of students couldn't do this problem, college students, okay? Partially probably they did not have enough training. So this is algebra, okay? Many students are supposed to learn algebra very well, in high school, middle school. So I want you to try first, okay? I want to see if any of you get the right answer here before I show you, okay? I'll give you 1 minute. Eric, I think you made a mistake. Okay, those who post answers, please double check your work. So Erica, you're giving 2 answers now. Richard, can you do the problem? All right. Yeah, this is tough, right? So remember, at what point you can remove the parenthesis, absolute value symbol? Only when you only when you use this form, okay? Or in this form. Okay, got it? Then you can remove the parenthesis, okay? That's only one of the 2 forms. So let's simplify this notation. Okay, simplify this inequality. Keep the absolute very simple. What you should do, you have to move 1 to the right hand side. And then -6 minus 1 will be -7. Got it? At this moment, you still cannot remove the absolute very symbol. You have to divide both sides by -2. When you divide by -2, okay, you will get 7 divided by 2, so 7/2. Okay? Yeah, be confident, okay? All right, so x minus 2 is less than absolute value. Then you can remove the absolute value symbol. Then you move 2 to the both side. Okay? Then you solve the problem. Okay? All right, so the left-hand side will be -3/2. The right-hand side will be 11/2. Okay, who got the items? Vincia did good. Okay. Nina. Anyone else get the same answer? So, yeah, this you have to, before you remove the absolute symbol, you have to get to the simple form, just absolute value of x less than 8. Then you can remove the absolute symbol, okay? So this is a place where you can use. Before that, you cannot just simply get rid of the absolute symbol. Clear? All right, so if you know how to do it, let me ask you to do the next one. 1 minus absolute value 2x minus 1 less than -7. Please do this. Okay. All right. Anyone have answers? Erica? So x is greater than. Now you should write all. You cannot put x like this, okay? You cannot put them in the one line in inequalities. You have to say x greater than. I'm not sure x is greater than 7/2. Then x is greater. No, that's not the correct notation. Okay, x greater than 9/2. That's correct. But you cannot write the inequality like that. Then you write. Good job. Yeah. Excellent. All right. All right. So first of all, you move 1 to the left-hand side, to the right-hand side, okay? So you get, right? Then negative 2x minus 1 less than negative 8. Then you multiply both sides by negative 1, so you get greater than 8. Then you can apply the following formula. X will be less than negative 8, or x is greater than a. Here a is positive, okay? Otherwise it doesn't make sense. Okay, so 2x minus 1 less than negative 8, or 2x minus 1 greater than 8. Okay. Then you solve each inequality. 2x less than 1, negative 8 plus 1, negative 7. Let's do like this, and it's going to be 9. Then you divide both sides by 2. Okay. So if you want to use the interval notation, that would be, this inequality would be negative infinity to negative 7 over 2, or this inequality would be 9 over 2 positive infinity. Then you can use, you can combine them. That would be the union of. Okay, why is the union of this, right? Because this is in either of the intervals. So I can say that you either live in Indiana, or Illinois, or Washington, or Kentucky. I list all those 50 states. Then I can always say that you live in the United States of America. Okay, United means union of these all states. Okay, so the x is in the interval on the left-hand side or in the interval on the right-hand side. Then x is in the union of these two intervals. Okay, that's a notation, right? So that's the union of these two intervals. Okay, so when I say x is greater than, for example, greater than 7 over 2, if I put the and, x is greater less than 9 over 2, for example, okay, then in this case, okay, the interval for this one will be negative 7 over 2, be careful, and x from negative infinity to 9 over 2. So x is either in this interval and x is in the other interval. So that is equivalent to x should be in the interval, the intersection of those two intervals. Now the intersection of those two intervals actually can be combined into one interval, okay, which is going to be negative 7 over 2, 9 over 2. Now why? Let me explain to you. Okay, this is 0. That's a 9 over 2. That's negative 7 over 2. Okay, so x is in the interval from negative 7 to positive infinity. Okay, let's draw this. Okay, so this is means x is greater than negative 7 over 2. And but at the same time, x should be in the interval less than 2 over 9 over 2. So this is x less than 9 over 2. So then x must be in the intersection of those two intervals. Intersection of those two intervals would be here. Okay, so this is the union, the intersection of the two intervals. Okay, intersection of those two intervals. So that's why you can simply write as this. Yeah, so intersection, that we can intersection this part. This is the overlap part, okay? Yeah, that's the intersection part. Okay, so that's the intersection part. The intersection of these two intervals. All right. Let's try another problem. 5 minus 2x minus 3x minus 1 is greater than is greater than if I use if greater than 2. All right, so let's do this problem. Please work on this. Yeah, definitely there's a solution here. Okay, because if you make the absolute value to be 0, then yes, 5 is greater than 2. Okay. Right. So I got Eric. Eric always does very fast. Good job. All right, I don't know the answer yet. Okay. Let me try this. Okay. Okay, Nina has the same answer. So first of all, you move 5 to the right-hand side, get -3, right? 2 minus 5, -3. Then you divide by -2. So you have to change the direction of the inequality. So -3 divided by -2 will be 3/2. Then you get rid of the absolute value symbol. Okay. Then you move -2 to the both side. And the 3 plus 1, 3/2 plus 1 here, -3/2 plus 1. So let's simplify this a little bit, okay? So this side will be 5/2. This side will be -1/2. Okay? Then you divide both sides by 3. So it does need to change the order. Okay, this will be -1/6. Good job. Okay, so that is the answer. So it seems to me everybody understands the inequalities. Okay, great. And you just needed to practice and finish the homework. Then we'll move on to the next section. I think the next one is about the applications of inequalities. It's about word problems involving inequalities. Then after that, we're going to study number theory. Okay, again, but it's a different level.